So in this video we go over how to find a unit vector. And what we want to remember is when we say unit, we're just indicating length 1. So a unit vector is going to be a vector of length 1. The unit circle is a circle whose radius is 1. A unit square is a square whose side lengths are all equal to 1. So in this context, we want something that has length 1. And the claim is that if we have a non-zero vector u, and we multiply u by 1 over the length of u, that will get a vector that has a unit length, or whose length is 1. And we call this vector u hat. So the hat notation will indicate a unit vector. V hat would be the vector of length 1 named v. So u hat equals 1 over the size of u times the vector u itself. And you could verify this pretty easily because in the previous video we said that if we have a scalar times a vector and we want to know the size of that vector, that we just need to take the absolute value of the scalar k and multiply it times the size of the vector. So in this case, if I look at this here, if I want to know the size of u hat, I would just take the absolute value of 1 over the size of u, which is a positive number to begin with, so I don't even need the absolute value symbol. And then by this definition that we just proved in the previous video, we would then multiply by the size of u. And you can see the result of this is we wind up getting the size of u over the size of u, which is just equal to 1. So indeed, if we multiply a vector by 1 over its length, 1 over its magnitude, we get a unit vector. So here's an example of how we could apply that. Let's find a unit vector, a vector of length 1 that points in the same direction as the vector v. So what we would need to do then is find the size of vector v. And the size of vector v is just going to be the square root of the sum of the squares of the vector components. So we get the square root of 9 plus 25, which is just the square root of 34, which is 2 times 17, the product of two prime numbers, so we know it's in simplified radical form. And our unit vector in the direction of v is going to be v hat equals 1 over the square root of 34 times the vector v itself, 3 comma negative 5. And you can think about this geometrically. What's happening is you're starting off with a vector v whose length is the square root of 34. So this is vector v. And then by multiplying it by 1 over the square root of 34, you're actually, in this case, shrinking it down so that you have a vector parallel to this one, but whose length is just 1 unit.